Hi, it's Jason here. Welcome to part 2 of my linked list series of videos. And in the previous part, what we did was basically introduced what a linked list was, drew some pretty pictures, and then finally created the data type in C. And now what we're going to do in this video, and for the next few videos, is to start implementing some basic interface functions. And the ones we're going to do today are the ones you see here. newList, which basically creates a new list, and several lookup functions. numItems, which returns how many items are in the list, getTheElement, or the nth item, which tells you which item is at which position, and showList, which prints out the entire list. So that's the agenda for today. So without further ado, we'll start writing these functions. So if you recall, this was our definition of a list here. And now we're going to write these new functions. So we'll start with newList. Before we write any function, we should really test it first. So in our test list function, the first thing we're going to test for is creating a new list. So we'll say printf creating a new list dot dot. And then we'll do some tests, and after it's done, we'll say new list created, exclamation mark, new line. So to create a new list using only these interface functions, well, we have one here, and it's simply called new list. So we'll say list L equals new list, and how can we test that it was created? Well, using only our interface functions, because it's an abstract data type, remember? Well, currently what we don't have a lot, but what we can do is test that it was empty. So when we call the numItems function, we should get a value of 0. So what we do is we assert that numItems of L should equal 0. Alright, so this means when we write this, let's write list.c. We need to write new list as well as numItems. So to make a new list, let's go back to our diagram here. We need to create this struct first, which is represented by the red box. And then to make it empty, we have to set the head to null. So that's the basic structure. So what we're going to do is, firstly, we're going to create a new list L, and when we create it, we're going to use malloc. Why? Because it's an abstract data type, and we don't know how big a list is. So when we ever use malloc, we have to input the size of the thing that it's pointing to as an input argument. So, but we don't know how big our list is, so we use the size of function, and the struct is called, that's a good thing I spelled that early. It's called a struct list. So malloc size of struct list. And then whenever we do malloc, we should always assert that the malloc worked. So in other words, assert that the pointer is not null. So now what we've essentially created is we've created this blue arrow, little l, and it's a pointer to this red box, which is our struct list. But we haven't set the head yet, so we have to set the head to null. So what we do is, using our diagram, the struct list has a field called head, but we have a pointer to the list. So what we have to do is take the pointer L, dereference it. So if L is a pointer to the list, star L is the list itself, or the struct itself. And then if we want to refer to a particular field of the struct, we use the dot. So star L dot, and the field is called head. And we want to assign this the value of the null pointer. Now this notation is fairly ugly. Computer scientists don't like it, and we often use a more convenient notation, which is represented by this arrow. And what this arrow basically means is that given a pointer to a struct, L, which is a pointer to a struct list, dereference it, and tell me what is at the field head. So to use this diagram, for example, if L is the blue arrow, then L arrow head is a pointer to the first node. It's really important that you fully understand this arrow notation, because in these linked list exercises we'll be using it quite a lot. Alright, so that's new list. Oh wait, we haven't returned the list, of course, so we've got to return the list. Okay, so let's just try to compile that. GCC minus whoa minus where minus big O minus little o, we'll call it list tester. And our two things are list.c and testlist.c. And there's an error. Oh, we haven't written numItems yet, or getNthElement. Whoops, I forgot to do that. Okay. So for the moment there, we haven't written getNthElement, but because we have to shut the compiler up for the time being, we're just going to return some junk value. This is rubbish, of course. We're shutting up the compiler for now. We will write this function later, but the function that we really have to write is numItems. So how are we going to go about doing this? So I have made another template here. To count the number of items, what we need to do is essentially follow the arrows until we reach the null. Okay, so how will we do this? First, we need to create a new pointer. We'll just make it purple because purple's cool. And we're going to assign it the value, or rather, we're going to make it point to the first node of the list. And note that if it's empty, like it will be when we create a new list, it's going to point to null. So now we have a pointer to the first node of the list. And then we check, is that the node that it's pointing to, is it pointing to null? Well, in this case, it's not. So we have to shift the pointer along, and we increment our count. So before it was 0, now count is 1. And we check again. This next node that current points to, is its next field null? In other words, is this arrow pointing to null? Well, no, it's not. So we have to go along to the next one. Is this the arrow that this is pointing to? Is it pointing to null? No, go to the next one. And then finally, is the arrow that current pointing to, the node, is the next field null? Yes, it is. So it's going to stop there. So that's the basic process we're going to use for looping through when we're coding our getNumItems. So what was the first step? The first step is we have to assign it to be the first node of the list. So that's fairly simple. What we do is, first we have to create a node pointer, we'll call it current, and we have to set it to the first element of the list, L arrow head. Notationally, L arrow head is this red arrow here, and it also happens to be the purple arrow here because they're both pointing to the same node. Okay, so that's cool. Of course, we also need a count as well, and we should probably return, initialize it to 0, assume it's empty at the start, return count. Now, to loop through all the nodes like I did, we're going to need some sort of a while loop. So here, what we're going to do is we're going to say while current is not equal to null. So whilst current is not pointing to null, well, we're going to do two things. First of all, increase the count. And second of all, we have to set the current to point to the next thing. Now this is a bit tricky. If we go here, currently it's pointing to this node. Current is pointing to this node. We want to make it point to the next node. So in the node field, we have two things. We have value and next. This black arrow here is the next field. So current arrow next is this black arrow. So if we reassign current to current arrow next, we'll shift it along. And that's the basic structure. So here we say current, assign it the value of current arrow next. So basically shift current to the next node. So this whole loop basically finds the end of the list, and then we return counts. Alright, so we've written our thing. Note that in this case, because we have an empty list, L arrowhead, which is this thing, which is what current is pointing to, is just going to point to null, so it's going to be empty anyway. So now that we've written that function, let's just check it compiles. This tester. All tests passed, you're awesome. Sweet. Okay, so we've implemented two functions so far, newList and getNumItems. We should probably fix that function that we did now, which is the function that we made was get the nth element. So to do this, we use the same kind of logic. In fact, all these basic functions use the same kind of logic of having this current pointer and shifting it along until we find the end of the list. So what we're going to do in this case, to get the nth number, instead of shifting the current thing to the end of the list, we're going to only shift it a few times, as many times as we need to. So we see it has two input arguments, list L and int position. In these exercises, because we're computer scientists, we're going to assume that we're counting from 0. So if there were 4 elements in the list, then the reference numbers are going to be 0, 1, 2, 3. Alright? So first, once again, we're going to have an int count. And the reason why we're going to do this is we're going to want to find where to place this current arrow. So we want to place it here. We're referring to the third element, or in this case actually the second element, because we're computer scientists and we count from 0. Let's just initialize that to 0. Once again, this is rubbish, we don't care about that. And of course we want to create the current pointer. So we'll create a node pointer current and set it to the head, which is the first node. Alright, and then we have another while loop. So while count is less than position. So if we want to find what's in position 2, currently it's pointing to position 0. If we want to find what's position 2, we need to shift it along 2 times. So actually, yeah. So that's why we have a less than sign rather than a less than or equal to sign. And then we have to progress our while loop somehow, and the main thing we're going to do is we're going to set current to be the next thing using the same trick we did before. And this is the main way we progress through a loop. So after we've done this, so say we're trying to point to this third node, and we start by pointing to the first node, we run the loop twice. Once, twice. And then we're pointing to the node that we want. And then we finally want the value inside this node. So what we're going to do is we want to return the value. So what we do is return current arrow value, because value is the number stored in this thing. Say we had like a 7 or something. Alright, and so that is get nth item. Now, fortunately we can't really test get nth item because we actually have nothing in here. But there's a couple of things we should do first before we finish off. We should check for invalid inputs. So firstly, whenever we take in a position, we must ensure that the position is legal. So the first assert is insert that position is greater than or equal to 0 because we can't return a negative position. And finally, we can't get something that's off the end of the list. So I'm going to say position is less than get numItems L. So that's the second assert we should have. Note that the less than sign is because if we have 4 items in our list, then the positions are from 0, 1, 2, 3. So that's why we use the less than sign. We can't, it makes no sense to talk about position 4 in this case. So that is our basic loop for get nth item. And finally, we're going to create a show list. So the show list is going to use pretty much the exact same logic as the previous 2 functions. It's going to, first we have our pointer current, which points to a node, print out the value, is it the end? No, shift current along, print out that value, is it the end? No, shift it along, print out the value there, is the end? No, shift it along, print out the value stored in here, is it the end? Well, no, shift it along, current, it's pointing to null, so we've reached the end. So that's the basic principle. So we're going to just use the same logic as, exact same logic as the one that returns the number of items here, but we're not, instead of counting number of items in the list, we're actually printing out all the items in the list. So we're not returning a count, so we don't need to do this. We don't need a count here. And instead of, so our action is we're not incrementing the count, now we're actually printing out the thing. So we've got a printf, and we will print out a list like this, %d, as a bunch of square brackets followed by arrows. And our input argument will be current arrow value. Alright? Referring back to this, current arrow value is basically the number stored in this node. Okay. And at the end, of course, we want to print the terminating thing. So now that once we reach the end of the list, we want to print out an X to represent the end. So now we've written our 3 functions that we wanted to write, and in fact we have another test. What we can do now is just ensure that it is empty by using showList here. And let's check that that compiles. So it compiled, and we can see here that there was an X here. So that means that the list was indeed empty. And we have implemented all the functions we have wanted to do in this video. So in the next video, we'll be implementing some more complicated functions, such as inserting and deleting. But until next time, see you later.